Today we're going to be looking at factoring part 2. Yesterday we looked at common factoring, so taking out the greatest common factor, and simple trinomials, so things that add to the middle, multiply to the end. And those are great, those are fantastic, but unfortunately not everything comes down to one of those two things. There are other types of things also. For example, we could have a trinomial which has a value out front, for instance this one right here, that cannot be common factored. I can't divide everything by 3. I get fractions or decimals, and we don't want those things. So when we come across something that cannot be factored out, and it's still a trinomial, we call them complex. Okay, so for instance, this one right here is a complex because of the 3. To do a complex trinomial, we have a little process we call decomposition. And there's 5 steps to it we're going to take a look at. We'll do some examples to get the hang of this. And these steps are used to do a process called decomposition. We break down this function. So what we're going to do first, and I'll show you with this example that we did up here at the top. Okay, we're going to multiply the first and last things together. So 3 times 2 makes 6. That's step 1. That's all you got to do. And then, sort of like a simple trinomial, we need to find things that add to 7 and multiply to this new number. So you need to make a list of your factors, maybe 1 and 6, 2 and 3. Which of those adds? Oh, 1 and 6 adds to 7. That's fantastic. Okay, there's my numbers I'm going to use. Now, instead of that being the answer, like it was for simple, that's a process in our answer. Step 3 says we're going to take the middle term, which would be the 7, and replace it with the 2 new values we just calculated. So the way it's going to look is the 3 stays the same, but now we have a 1x and a 6x replacing that 7x, and the 2 stays the same. So we've changed the way it looks without mathematically changing the question. 1 plus 6 still makes 7, we just made it look different. And now we're going to split this in half, like we did yesterday when we common factored. What can I take out of the first 2 things? An x. I'll be left with 3x plus 1. What can I take out of the next 2 things? A 2. And a little hint for you, whatever sign is out there goes down there, just like it did when we did common factoring yesterday. And what am I left with when I take a 2 out? 3x plus 1. Now you know you're on the right track if your brackets match, like they did yesterday when we did common factoring. In our case, they do. So the last step, step 5, we common factor again. I have a 3x plus 1, the entire expression that's common, and an x plus 2. And there's my factoring for a decomposition, a complex trinomial. Okay, we're going to try a couple. We'll go through the steps again and get a chance to practice these. See what you can do. Work ahead. If you get the hang of it, skip some, go to the next idea. Okay, step 1, multiply first and last. That's 4. Find numbers that add to 4 and also multiply to 4. Well, there's only one thing that does that, 2 and 2. So I'm going to replace the middle term with the 2 and the 2. No, notice this stayed the same and this stayed the same, right? Those don't change. Okay, step 3. Sorry, step 4 actually. Split it in half. What can I take out of the first half? Well, they both have 2x in common. What would we be left with? A 2x and a plus 1. Whatever sign is there, write it down. Okay, tricky part here. What's common to 2x and 1? Not really anything, right? But because of this idea of decomposition, I have to take something out. So we're going to take out a 1. And we don't usually call that a common factor, but we do for this case because I need to break this thing down. If I take 1 out, nothing happens, right? The stuff inside stays the same. But the good news is my brackets match. So I have a 2x plus 1 and a 2x plus 1. Which would maybe say, hey, that's the same thing twice. And if you want to, you could write it that way. Okay, we call that a perfect square, the same thing twice. We remember those as touching zeros, right? They come down, touch, go back up. Hey, you got to try the next one if you haven't done it yet. I'll take you through it in case you are stuck still. Okay, 2 times 6 is 12. What adds and multiplies? I got 1 and 12. Hey, 1 and 12 makes 13, so there's my numbers. Replace the middle term. The order you replace them in doesn't matter, okay? Not at all. Your choice, as long as the sign's right. Split it in half. Common factor each half. 2x and x plus 6. Nothing in common, so I take out a 1. X plus 6. My brackets. The common one and the leftover stuff. I'm done. Okay. And one more. You guys give it a try if you haven't done it yet. Hopefully this is the 4th one now. You can got the hang of this. Okay, 5 and 8 makes 40. What adds to 22 and multiplies to 40? So I'm not sure. I'm going to write down my factors. 140, no. 2 and, oh, 2 and 20 makes 22. Okay. Oh, but I need to be negative 22. So I need to have a negative 2 and a negative 20. And the good news about both those is when I multiply them, they become a positive, right? Which is what I want anyway. So that works out perfect for me. Okay, split it in half. I can take an x out. So we're left with 5x minus 2. This time I have a minus sign, so I'm going to write down a minus sign. And 20 and 8 are both divisible by 4. So 5x minus 2. Remember, positive 8 divided by negative 4 is negative 2. I know I'm on the right track, so my brackets match. And there is my answer. And that's complex trinomials. Okay. All right, last type we have to worry about. Okay, so we call it difference of squares. There's a special type of trinomial. It happens when you have no middle term. So for example, this x squared minus 4 here. I could write, if I wanted to, x squared plus 0x minus 4, but we know that 0 something, we don't usually write that. Okay, so it's a special version of a trinomial. 3 terms with the middle one missing. Okay. What happens here is we've ended up with something strange happening in the middle. And we can recognize these because there's only 2 terms. There is a minus sign. And you go back to the original thing here. Okay, minus sign. And I can actually square root them. And the idea of square rooting means that it's actually been the same number twice. If I think of this, what adds to 0 and multiplies to negative 4, the only thing that does that would be x and x, 2 and 2, and they have to be opposite signs in order to add to 0. Or if I think about it, square root of 4 and the square root of 4, right? So that makes my life easier. Okay, one sec. Okay. So the big point here is if I ever get something that has 2 terms, a minus sign in the middle, and I can square root these 2 things, we call that a difference of squares. And the answer turns out to be the square root of the first thing at the front and the square root of the last thing at the end. Just like this one over here, the square root of x squared was x and x, and the square root of 4 was 2 and 2. Just be careful, you have opposite signs between them. There's one thing I have to add at the end here. Sometimes with the difference of squares, you can end up with brackets. Let's say I had x squared plus 1 and x squared minus 1. Looks like a difference of squares. But this bracket can actually go further because it meets the conditions for another difference of squares. There's 2 terms, there's a minus sign, and I can square root them. So if I end up with something like this, I'd have to do a difference of squares all over again. And I couldn't do it this part up front because there's a plus sign, doesn't meet the conditions. And I couldn't do it again because I can't square root x. I need an exponent to be able to square root something. I need to be able to cut it in half, and I can't do that. Okay, but there are some times where, back to this first line here, I can't go further. We'll do 1 or 2 of those today so you can see how that works. Okay, so let's try these things. Hey, so I'm writing them the weird way, the way of the zeros in there, just to get the hang of this. Can we think of things that add to 0 and multiply to negative 4? Well, we just did this one, right? And we said x and x. What multiplies to 4? Well, 2 times 2. And to create a 0, I need 1 plus and 1 minus. Let's take a look at the next one. What adds to 0 again multiplies to 36? Well, I need an x and an x. Things that multiply to 36 that come out to 0 to be the same signs. In other words, if I square root 36, 6 and 6, and make one of them a plus and one of them a minus, that would add to 0 and multiply to 36, negative 36 specifically. Okay, I'm not going to put the 0 in there anymore, but we can still think of that. What adds to 0 but multiplies to negative 100? Well, 10 times 10 makes 100. And to add to 0, I need 1 plus and 1 minus. And the order of the signs doesn't matter, okay, as long as you have 1 of each. I notice I put plus every time, it doesn't make a difference. Okay, ooh, x squared minus 400. Whenever I have to add to 0 in the middle there, square root of 400 is 20. To add to 0, I need one of them to be a minus and one of them to be a plus. Okay, getting the hang of this? Ready? Our shortcut idea, right? I like this shortcut idea because when I get to something that looks more complicated, like the letter E here, I can say, okay, square root of 4x squared, that's 2x. Square root of 25, that's 5. I need to write it down again because I need two of the same brackets, but opposite signs. Okay. And if I tried foiling, I could check it if I really wanted to. 2x times 2x is 4x squared. 2x times 5 is 10. And negative 10 cancel each other out. And 5 times negative 5 is negative 25. Okay, letter F. Square root of 9x6. I need half to go in this bracket, so 3x3 and 3x3. 64y squared, well, square root of that would be 8 with a y and 8 with a y. And you 1 plus and 1 minus. Okay, when you're doing the letter parts, like x6 here, half goes here, half goes there, right? That's how you square root an exponent, half and half. Okay, a couple more little ones to try. x4 minus 1. I can square root x4. If I cut that in half, I've got x squared plus 1 and x squared minus 1. Now this is one of those ones I talked about at the beginning here. I look at this bracket over here, the right-hand bracket, and I notice two terms, minus sign in the middle, and I can square root things. The left one has a plus sign. It can't go further, so I write it out again. But the right one becomes x plus 1 and x minus 1. I can do a difference of squares with that half. I can't go any further because I can't break this piece in half anymore. And because the first two have plus signs, I definitely can't go any further with that. Right? You can't do things with plus signs. It has to be a minus sign in the middle. Let's take a look at H. Okay, square root 16x6. Yep, that'll be 4x3 and 3, 4x3 and 3, and 1 plus, 1 minus. Can I go further? Got minus signs. I've got two pieces. I can square root 4. Can't square root x3 though. I don't want decimal exponents. I also can't square root the number 3, so I know I'm done. Okay, last one. Square root of 2. That's a big decimal. I can't square root 2. But if I notice that these are common, that have something in common, for instance, I could take a 2 out, and 1250 divided by 2 is 625. I can common factor first. Common factor is one of those skills that we can use in any type of factoring. Just regular common factor with a simple trinomial, with a complex trinomial, with a difference of squares. Don't forget that if you can find a common factor, you should do that first. Now if I look at my brackets, I can say to myself, oh, okay, I can divide x4 into x squared. Square root of 625 is 25. I need two brackets that are the same. I need 1 plus and 1 minus. Hey, look, this first bracket here has two terms. It's got a minus sign in the middle, and I can square root those things. So I got to do it again. Square root of x is x. Square root of 25 is 5. Square root of x is x. Square root of 25 is 5. Different signs in the middle. I can't do the next one because there's this plus sign here, so I just write it out. And that's all I can do with that one. Can't go any further. I got plus signs and brackets, or I've got things that can't be square rooted anymore. Okay, and that takes us to the end of difference of squares, or factoring part 2. So you now have 4 different types of factoring. Regular common factor, a simple trinomial, a complex trinomial, and a difference of squares. For today, they're going to tell you which ones to do at each time. Tomorrow, we're going to start mixing them together. So we'll go through like a flow chart of how to decide which one do I do and when do I do it. You definitely need to practice these ones so you get really good at factoring, because that's part of what we're going to do to be able to solve any of the rest of our problems, okay?